Hey guys and gals, it's me back again. Sorry I can't be there. Um, the old leg needs some surgery, so I'll keep making these videos and you can ask me questions if you have them. Hopefully what I'm doing makes sense. We are going to do the opposite today of what we did yesterday. So yesterday we would take an angled vector. Here's a recap of yesterday. Let's say it's a 100 Newton force, and we'll call it vector C, right? And it was at a, let's say, 40-degree angle. So what we did yesterday was we found the force of this that goes up, force of C in the y direction, and we found the force of this that goes over, right? And quick recap, if you remember, to find the x part, you would do the diagonal, so FCX. You do the diagonal times cosine of the angle. You got to remember that. Cosine goes for the left and right part, and the other part is FCY is the diagonal times sine of the angle. Pretty easy. As long as your calculator's in degrees and you remember that sine goes with vertical, cosine goes with horizontal, you're going to be good to go on like 90% of your problems. Okay, so that was taking a diagonal and splitting it into its horizontal and vertical parts. Well, today we're going to do the opposite of that, but you'll see some similarities, which is kind of cool. We're going to take the two parts and try to find out the magnitude or length of the hypotenuse and the direction or the angle down here. Okay, so the first thing you need to do is determine the sense of where the vector will be. Sometimes it's hard to tell from here, although your common sense, if it's pushing, you have a force pushing up and a force pushing right, then the vector itself will go up and to the right. Now, instead of just guessing, you can actually figure out where exactly the vector starts and stops by lining these up instead of both starting at the same base, by putting one vector on the, you go tip to tail. So if this one goes to the front here, the other vector, I'm going to, instead of laying it down here, I'm going to start it up here and have it go the same length horizontally, same direction. Okay. Now, if this is the y part, force of A in the y direction, force of A in the x direction, then your resulting vector, or resultant vector, that's our vocab term for this, starts here and ends there. This is vector A, which is kind of crazy, right? Now, it didn't matter that I took this guy and put it up here. I could have also taken this guy and started it at the tip of that one, and it would have matched in the exact same spot. So the sense of this is up and right. Okay, now I'm going to skip ahead to a different one. Kind of like last time, this is the easiest one. So I want to do, let's do C now. Let's do C. Because just like last time, you have to watch out for negative signs, and it doesn't come through in the formulas. You got to use your good old common sense. So once again, I'm going to go tip to tail, and it doesn't matter if these are where they're both, you imagine an object here being pushed that way, being pushed down. Well, then the resulting vector, resultant vector, will be down and to the right. Okay. So we're going to first draw it. So it doesn't matter if I move this over here, or move this down here. Kind of whichever thing you want to do. What did I do last time? I took the horizontal part up. So now I'm going to take the vertical part and move it over. Like I said, it doesn't matter as long as the tip ends here and it starts the new tail. Okay, so I just transpose this one over here. And then you can see your resultant vector goes down this diagonal. Well, those are pretty nice lines for no ruler. Crazy. So this guy I just drew is vector C. All right, now I need to find out its magnitude, that's its size, and its direction, and make sure you always find its direction. I'm going to put a theta in here for now. It's like the angle version of x. Always make sure you find the direction with the x-axis. Okay, if you remember to yesterday, every one of those angles was with the x-axis, the 40 degrees, the 65 degrees. Notice I never go to the y-axis. No one will. No math teacher will. No engineering teacher will. You always go to the x-axis. Okay, so what's my formula? The easiest thing to find in this first is the magnitude. The magnitude, I should write that here, magnitude of vector C. Okay, and that's like if you look at your steps, there, determine the sense, we already did that. Select the appropriate formula. Now this is actually not a bad formula. I'm going to write, this was down here, I'm going to write it over here. Force of C in the y direction was 250 pounds of force. The force of C in the x direction is 125. So it's kind of pushing more down than it is right. What's cool about this is it's a right triangle because you have a strict horizontal motion and a strict vertical motion. Well, lucky for you, you've been doing this formula your whole life. It's a formula that involves the three sides of a right triangle, and that's here. So we have a squared plus b squared equals c squared. And you got to make sure, the only thing you have to be careful on this one is the hypotenuse. Math teacher me loves this part. The hypotenuse is by itself, so that's what I'm trying to find for, and well, that's kind of cool because it's actually a c this time. Magnitude of c, usually they put absolute value looking signs around it if you want the magnitude of a vector. That's a math thing. But what am I going to put in for a? I don't know. Let's call this one a and this one b. So we're going to have 125 pounds squared plus 250 pounds squared. Imagine I wrote pounds in there. I didn't really have room. Equals c squared. So then we'll have c squared, magnitude of c squared is, let's see, it's 125 squared plus 250 squared is 78125, right? 78,000, and that's pounds squared. But then I'm going to square root both sides, and the magnitude of vector c is the square root of that. I'm going to do square root of my answer, 279.51 pounds of force. So what's kind of cool is if you push something 125 pounds of force just to the right and 250 pounds of force down, straight down, it'll be the same as you pushing it on this diagonal at 279.51. I just got to know the angle. So this part's easy, right? The only hard thing in here is finding the angle, and that's what we're about to do. So if you look at our steps, we determine the appropriate formula, we found the sense, we solved for the vector value, we drew it already and labeled it. I mean, the label's right there, vector C. Oh, my cat just ran into my foot. Stop it. Ow, that hurts. Okay. Gosh. Now, our last thing is probably the weirdest part, and that's the direction, the angle. This is the hardest thing to find. Once again, make sure your calculator's in degrees, right? Second thing, from this angle's perspective, remember the whole SOHCAHTOA thing? Right? From this angle's perspective, you have opposite, which is the y part, and adjacent. You don't know hypotenuse. I would not recommend, you could use that, but it's already rounded, and if you round your answer afterwards, you can be off by a couple decimal places. So I never use a rounded answer to find my answer. There's another reason too. What if you noobed it up and you made a mistake when you're typing it in and this answer's wrong? If you use that to get another answer, guess what? Your next answer is guaranteed to be wrong if this one's wrong. At least, even if you mess this up with a rookie mistake, you can still get full credit on this next one if you use the original numbers, and then you don't have to worry about your other mistake. But common sense should tell you the hypotenuse is going to be the biggest number anyway. So if you got a number that wasn't the biggest, you got a problem. I guess you might have thought like 78,000. That's a little too big with only these two forces. All right, so let's actually do it. Which one of these three uses opposite and adjacent? Well, I should see one with an O and an A. Hey, winner, winner, chicken dinner. I'm going to use tangent. So, tangent of my angle. Now, this time I don't know. Remember the last problems, I actually could write a number in there. Tangent of my unknown angle, called theta, equals opposite over adjacent. That's what TOA is, opposite over adjacent. Tangent is opposite over adjacent. The good news is you get to do this every time. It's always going to be tangent, and the next step is the only weird step. Opposite is always the y part. I say always, okay. 99% of the time it's the y part. Adjacent is 125. The pounds cancel out. Now here's the tricky thing. No, you cannot divide by tangent. That's illegal in math. This is not tangent times theta. It's tangent of theta. There's only one way to undo tangent. The undoer of tangent is right above tangent. Do you see it? It's called inverse tangent. Okay? So inverse tangent is what I'm going to use to kill this tangent. Well, if I inverse tangent this side, guess what happens? It turns out to be just theta. If I inverse tangent this side, I'm going to get my answer. So I'm going to write this out one more time. Usually I don't write this much. I would have just gone from the original setup. Actually, I could have just gone to this setup. It's kind of nice to put the opposite over adjacent so you don't mess up. Opposite is like you put your eyeball there and look opposite yourself. You find it. It's the y part. Okay, so now all I got to do is type this in. Make sure you use the inverse tangent button, which is second, and then tangent. Even if you're on a TI-30, it's the same. And then 250 over 125. Hit enter, and you get 63.43 degrees. Now, does that pass the common sense test? You should always check. Does it look like about a 60-degree angle? Heck yeah, it does. Especially because there's more going down than there is going sideways. If these were both the same number, you get a 45-degree angle. So if it's pushing down more, I expect a number bigger than 45. If it were pushing sideways more, I would expect a number smaller than 45. So this one kind of passes the test. You know another way you can tell? Do what we did yesterday. Like, pretend this is a problem. By the way, this should be negative 250. It doesn't change the tangent, though. So on this one, imagine I had a vector that was 279.51 pounds of force, and it was at a 63.43 degree angle. How would I split it into its x and its y part like we did yesterday? This is a great way to check your work and review. Well, I would take the diagonal, 279.51, times sine, if I want the y part, right? 63.43 degrees. Is that about what my y part is? Yeah, except it would be negative, but it goes down. That's super close. It's just off because of my rounding. And if I want the x part, I just do the same thing but with cosine. So this is a good lesson to review. Boom, 125. Awesome, did it right. The only thing I don't like about this is that should have been a negative 250 because it's downward. All right, awesome. I think you can look at this, go back, try the other problems. It's always going to be Pythagorean theorem. You're solving for hypotenuse. It's always going to be tangent, opposite over adjacent, or y over x. And use inverse tangent to undo it. Okay, every time. And you should be able to crank through these. Email me if you have questions. Adios.